Hello guys, welcome to my YouTube channel I Become Engineer. Okay, today we talk about topic is wrong three-phase motor connection. What happens actually? Okay, so let's get start. Many electricians believe if the motor is running, the connection must be correct, but that is not always true. A motor can rotate and still getting damage internally. Just swapping two wires can change direction. One missing phase can slow burn the winding, and a wrong voltage connection can reduce motor life decreasingly. Today, I will explain what actually happens inside a three-phase motor when the correct connection is wrong. Okay? Okay, the first point, how three-phase motor normally works. A three-phase motor works because of something called a rotating magnetic field. When we give three-phase supply R, Y and B, each phase current is 120 degree apart. Because of this time difference, a magnetic field is created that rotates inside the stator. That rotating magnetic field pulls the rotor and that produces torque. If the phase sequence is correct, the magnetic rotates in correct direction, so the motor rotates normally. Okay, the important things to understand: the motor does not rotate because of voltage alone, it's rotates because a rotating magnetic field. Okay, so case 1, swapping any two phases. Now let's talk about this simple mistake, swapping any two phase. For example, RYB sequence become RBY. What happens? The phase sequence changes. When the phase sequence changes, rotating magnetic field also changes direction. And when the magnetic field changes direction, the rotor also rotates in the opposite direction. Okay, so very important point is, in this case motor does not get damaged, only direction change. Okay, but sometime simple mistake can become dangerous. If a pump rotates in reverse, water will not flow. If a conveyor rotates backward, production may stop. If a compressor rotates reverse, internal mechanical damage can happen. So swiping changes direction, not motor health. Okay, case 2, single phasing, most dangerous. Now let's talk about a more serious problem, single phasing. Single phase means one phase is missing, maybe because of loose terminal, maybe because of blown fuse, maybe because of supply problem, but only two phase reaching the motor. What's happened now? The motor still tries to run, but two phase are still producing some magnetic field. But that magnetic field is no longer balanced, that becomes weak, and when the rotor experiences unwound torque, and something very important happen internally, slow down voice. The current in remaining two phase increases. Okay, when one phase is missing, the motor draw more current from the other two phases to maintain torque. High current means higher heat, and heat is the biggest enemy of motor insulation. Okay, copper loss is proportional to I square R. So if current increase slightly, heat increase significantly. Okay, so motor does not burn instantly, it gets heat gradually, insulation weakens, turn may be short internally, finally winding burns. Okay, many motors burn not because of overload, but is because of single phasing. Case 3, wrong voltage connection, star delta mistake. Now let's talk about another common mistake, wrong voltage connection. Every three-phase motor has nameplate, a clearly mentioned voltage rating of star and delta connection. For example, 415 volt delta and 660 volt star. Okay, if we connect wrongly, serious problem can happen. Continue. Okay, in star connection, each winding receives lower voltage. In delta connection, each winding receives full line voltage. Okay, I am again saying that in star connection, each winding receive lower voltage. In delta connection, each winding receive full line voltage. Okay, now imagine this motor is designed to run in star at 415 volts. Okay, but someone connects is in delta at 415 volts. Okay, each winding now receives higher voltage than its design limit. So current increase, heat increase, insulation stress also increase, motor life reduce. Opposite mistake also create problem. If motor should run in delta but connected permanently in start, torque becomes low. Motor may start without load, but under load it struggle. Current increase, heating increase. Okay. Okay. Next point is what happens internally during wrong connection. Again, I'm saying that what happens internally during wrong connection. Let us understand internally what actually changes inside the motor. First, magnetic field becomes unbalanced. Second, current increases in some windings. Third, temperature rise. Fourth, insulation weakens. Fifth, small internal short circuit start. Initially, you may not notice anything. Motor may look normal from outside, but internally damage is happening slowing. Okay, so motor failure is usually slow process, not instant explosion. Okay, I'm again say that motor failure is usually slow process, not instant explosion. Okay, next point, why many technicians miss this, or why many engineers miss this. Many engineers only check whether motor is running. They do not check phase sequence, line voltage, current balance, motor nameplate rating. Because of that, motor runs week of month. So because of that, motor runs for weeks or month, then suddenly it's burned, and they think motor quality was. Then suddenly it's burned, and they think the motor quality is bad, but the real reason was wrong connection. So final. So today we clearly understood swapping to phase changes direction but does not damage the motor. Single phasing increases current and heat and slowly burn winding. So again, single phasing increase current and heat and slowly burn winding. Okay. Voltage, wrong voltage connection increases stress on insulation. Inside the motor, damage start from heat and magnetic imbalance. Before energizing any motor, always check phase sequence, voltage rating, current balance, and proper connection as a nameplate. Okay, because of a motor rotate correct because of a motor rotate correctly, but internally it may already be dying. Okay, so if you like my video, please subscribe my YouTube channel, I Become Engineer. Thank you very much. We will meet our next video. Thank you very much.